Good morning, everyone. Welcome to Coreform and welcome to our webinar, your first 15 minutes with Coreform Cubit. Our host today is Greg Vernon. He's one of our Cubit experts here at Coreform. And if you've seen any of our other webinars, you'll recognize him. He does most of these for us. Our agenda today is pretty simple. We're going to just give you a quick overview about Coreform, quick overview of Coreform Cubit. Greg's going to talk to you about how Cubit is best used, and then he'll walk you through a live demo of just the very beginning basics of getting started. He'll log in, import a CAD model, create a simple mesh, and so on. And then we'll move on to our Q&A. So Coreform was founded in 2014. As a company, we're primarily investigating next generation finite element analysis. But we also sell Coreform Cubit, which is developed by Sandia National Labs. We work with them as a co-developer and distributor of Coreform Cubit. We're also developing a next generation solver, Coreform Plex, which is in progress. If you have any questions about that, or if you'd be interested in knowing more, feel free to let us know. We're always happy to talk to potential customers. Coreform Cubit is a high-end hex meshing software. It's used primarily in high-end structural engineering. It's also used in CFD, with neutronics, lots of applications where people need hex meshes and fine control of their mesh. So we won't go through all of this today, but if you're interested in Cubit, some of its features include CAD import and cleanup, semi-automated hex meshing, the ability to have fine control over your mesh and its quality and properties. Fantastic Python scripting, also our own journal language. Greg will talk to you a little bit about that, and flexible licensing. After this webinar, if you're interested in learning more, you can go to our website, go to support and then documentation. You'll see a page that looks like this. We have lots of tutorials, PDF learning manuals, whatever your learning style is. And we have a lot of videos on our YouTube channel. This webinar will be posted there when it's finished as well. Okay, that's it for me. Thanks for attending. I'm going to pass this on to Greg.
Thanks, Kim. I'll go ahead and get my screen share going. Yeah, so as Kim mentioned, this is the intention of this webinar is to kind of give you your first 15 minutes with Coreform Cubit, get you oriented to the tool and some of the basics of the tool so that you can start to have success. And so the very first thing that I want to bring up with our latest release, which is the 2025.8 release of Coreform Cubit, we have updated the GUI with new icons that are scalable icons to better support high density pixel displays. And so you'll notice that some of the icons have changed. And so if you're on an older version of Coreform Cubit, you might see the icons are a little bit different. But the overall structure is still the same. Just to review a little bit, we have a menu bar as well as a toolbar with icons that help you kind of quickly access certain features of Cubit. We have in a graphics window where the model you're trying to mesh will appear, and you can make selections such as I've made here. As you make selections, there's a properties panel that can give you some quick information about whatever entity it is that you've selected. There's also a model tree. The standard model tree view kind of gives you an overview of the different volumes that are available, as well as some entities that we'll talk about in a little bit. There's also a command line. Cubit was originally developed in the 1980s and throughout the 90s, prior to there even being a GUI at all. And so it was completely a command-driven tool. So you can see here, I've got a command ready to go to list information about this selected surface. And then as the GUI came around, we added a command panel that provided kind of quick access to creating these commands. So every command that you could run through the command panel has an equivalent command in the Cubit command language. There's also a couple other things that are useful. You'll notice here I switched my tab on the bottom right here from command panel to power tools. And this is where we're going to start for your first 15 minutes. I tend to find that this is helpful for, especially for folks who are new to even meshing at all, to kind of get a feel for the flow of meshing. Um, and then you can come back to the command panel as you become more experienced with the functionality and more comfortable with the layout. As well, I mentioned we have that command language. I'll oftentimes talk about the history of what you've done. And so by switching different tabs on the bottom, you can get information about, either from typing in commands or errors, getting error messages, seeing the history of what you've done, switching from the Qubit command language mode to a Python command language mode, which we'll go over later. What I want to mention first, though, what I think it's critical to understand about Qubit is that it was based around the Exodus mesh format. So we noticed that in our model tree, there's this idea of block, side set, node set. Those come from the Exodus mesh format. Exodus is an open source mesh format that was, again, developed by San Diego National Labs, and it is part of their CCAS project, which you can find on GitHub. And there's a lot of documentation and a lot of additional tools for Exodus there. Being open source and attached to Sandia, Exodus also enjoys a lot of support from other open source tools like ParaView. And then Coreform Cubit also then supports translating some of these core data types that we'll talk about on the next slide into different mesh formats such as Abacus, ANSYS, Nastran, OpenFOAM, and more. If you have mesh formats that aren't included that are important to you, feel free to let us know on our forum or via email. And then just a high-level overview then of the Exodus mesh format, specifically those data types. There's this idea of a block, which is kind of it's a set that is primarily used by most solvers to assign materials or element formulations to. You might want to apply a body load. While we show an icon of a volume, you can obviously, if you're doing a shell analysis, a block can also be assigned to a surface, but it's really about, this is where I want to assign some sort of materials formulations. It defines the overall element connectivity. There's then this idea of a side set, which allows you to select then kind of sub entities of whatever your block is, such as a surface or edges. And the key thing here is that side sets retain kind of some of that information about the connectivity. So they're ordered, which allows you to do integration, compute normal directions per element face or per element edge, which are oftentimes necessary for various different kinds of load and boundary conditions. And then lastly is node sets. In traditional FEA, we might assign a Dirichlet, such as like a displacement boundary condition or a temperature boundary condition, directly onto the nodes. And so node sets give you that access where we don't need the connectivity information anymore. So it's just a grab bag of nodes. The next thing I want to talk about is building contiguous meshes in Coreform Cubit. If you're familiar with other meshing tools, such as you might find that come along with their solvers like Abacus CAE or maybe ANSYS meshing like ISIM or HyperMesh, they'll all have different ways of building contiguous meshes. In Qubit, what we do is we call the operations that decompose a geometry entity into we call that a web cut. And those create disconnected regions, and you'll not get contiguous meshes, essentially where the nodes are shared between bodies. So there's two tools that are oftentimes used to create those. One is imprint, and what that does is it translates topology or copies topology from neighbors onto each other. That oftentimes gives you these duplicate co-located entities, and then merging can then stitch those together to be a single entity that's meshed, and that enforces this continuity of your mesh. So just to show an example of that, here I've got two objects. I've pulled the cylinder away from the cube here, just so that you can see clearly that there's a gap there. that these are not connected. And so obviously, if I build a mesh on these, I can have two wildly disparate meshes, and there's no information being transferred between the two meshes. So what the imprint operation does is it's grabbed, it's evaluated all the curves on the cube and says none of those curves can be projected onto the actual physical geometry of the cylinder, but the cylinder's circle from its circular shape can be imprinted onto the cube. And so now we have a new circular surface on the cube. I can mesh those, but they are still not contiguous. So I can still clearly have two completely different meshes on those two surfaces. What the merge operation does is it now says, hey, these two surfaces are the same surface. Remove one of them and just treat the one surface from a topology standpoint. And so you can see here just very clearly that as I built this mesh on this top surface here, it is now forced to use those same nodes that are on the cylinder. And you can see that even the actual black curve is missing from this circle. There's only a single curve and a single surface that represents that. And so that's why now we have this connected mesh. Obviously, that doesn't look like a good mesh. In practice, you won't have this very large gap. They'll actually be connected, but that's what's actually going on behind the scenes. There's a couple of useful tools to be able to verify if you've merged that topology, so you'll get a contiguous mesh. One is with a tool we call the curve valence tool. Essentially, what that means is that wherever you see, if you activate this icon in the toolbar, white entities are where they've been merged, and blue entities are unmerged. So you can see these exterior or external curves are still blue because they're not merged with anything. They're just the boundary of our shape. And then I can verify that, say, this surface, this rectangular surface, is merged because all of its curves are white. Alternatively, sometimes what I'll do, these can get very complicated sometimes, is I'll issue a command to Cubit to draw a surface is merged, and that's a property that we track whether or not entities have been merged or not, and then you can actually visualize those entities. And so typically here, if you started to see like a gap, you'd be like, why is there a gap there? Oh, because there's no geometry. Or you might see a gap and you might then look at your real volume and say, hey, there really should have been something there that got merged. The last thing I'll mention is being able to set options. This is really helpful. You'll notice that I like to use black curves and vertices because it just feels closer to CAD to me. And so if you go to Tools, Options, you have then various different kinds of settings you can choose, such as being able to modify the default colors for geometric entities. And with that, I'm going to go ahead now and do a live demo of Coreform Cubit. I'm going to start. One of the other big changes with 2025.8 is we've updated licensing to make it simpler, as Ken mentioned. So here I don't have a license for Coreform Cubit on my machine, but I do have a Coreform account that's been created for me. So I'm going to go ahead and just enter in my username, which is my email address, and my password. So I've entered my password. I'll say login. And now Cubit has shown up. And that only happens the first time that I open Cubit on my machine. It'll now retain, if I close Coreform Cubit, it'll now retain my login information for my subsequent startups of Coreform Cubit. If you want to verify your license status, if you go to Help Product Activation, you can then check your licenses through that same interface. One thing I might do here, I think my display is might be a bit fine for folks. So let me just increase the scaling on my system here to make this a bit easier for folks to read. Great. All right, so I mentioned that for new users, it's oftentimes helpful to use the power tools. So I'm going to go ahead and activate my power tools, and then this it's called an item wizard. which has a little wizard hat. And this is again just like this walkthrough of kind of the processes to do. So it starts from top to bottom. I want to import my geometry. So let's say I want to import a CAD model. And I have a CAD model that I've prepared here. So I use the dialog to help me prepare my CAD model or to import it. So now I'm going to click done. And then I'm not going to build my own geometry, so I'm done here as well. Now, I mentioned I kind of like the black curves. I find on my aging eyes, the lighter colors kind of are hard for me to see a lot. So again, I'm going to go to Tools, Options, Geometry Defaults, and then on Curve Color, I'm going to choose black. And then I can hit save, and now I can see I've got these black lines. Just to look at our geometry real quick, you can see I've got a lot of really small fillets, and I've got this whole, if I go to transparent mode, that goes maybe about 3/4 of the way through the CAD geometry. I know that these fillets are going to be hard to mesh, and maybe they won't really matter in my simulation I'm actually doing. So we'll use the power tools to help clean those up. The next thing I'm going to do though is coming down back to our power tool item wizard. The next item is set up FEA model. And what this is going to help me do is kind of get an idea for what I want. So I can say preview a hex mesh. Now I can't actually build the mesh, but I can at least see, given some sizing, how fine my mesh might be given a target mesh size. I can also specifically enter in like element budgets. Maybe I want like 10,000 element budget, and it will guess at a target mesh size for me. And so you can see here, there's this mesh size of about 0.043. That's all this is just getting some of the initial settings set up. We'll go ahead and click done. The next thing is to prepare my geometry. Under here, there's this run check diagnostics. If there are some diagnostics I don't want to do, I can uncheck them. I'm going to go ahead and run them. And it's looking for various different things that might be issues with my model. So you can see I've got maybe some issues with removing small features. So I click on that button, it takes me to the remove small features dialog. I can detect small features. So we find our small features first. Might need to set this a little bit larger here. There we go. So I'm detecting anything that's kind of smaller than 0.1, which I know to be kind of relevant for the size of my model for what's small. And so it's found a lot of small curves as well as small surfaces. If I click on these small surfaces, it'll highlight them in my model. What I can kind of see here is that I've got a lot of these that are very small. Or maybe not very small, but they're these fillets. And there are some remove surface options that I can use. And it's giving me some ideas for commands I could run to remove them. What I'm going to do is I can see that I have this remove surface that I can kind of preview what that operation is going to do by clicking on one of them. Get rid of the scale factor here. And if I go to then the remove surface dialog, you can see it's got this option for removing blend chains. So this has popped me now over to the command panel, and this is where the power tool can help me find commands in the command panel to become used to. So if I select one of those surfaces that it had highlighted for me with the remove blend chain option, it's now removed that blend chain for me. I can go back to the power tools, redetect small features, look for another small curve, and it's found that little small curve inside of there. So again, I'm going to go back to the remove surface. I've got that surface selected and remove it. But I can kind of now see that probably this surface is also going to be a small surface that I want to remove. I can apply that as well. So now I'll move back to my power tool, detect small features, and I don't have any small features now in my model. So now I'll click done. I'll rerun the check diagnostics. It's even said that now I even have a meshable topology. And so Cubit, this is where we say it's semi-automated. Cubit can recognize how to mesh this geometry now. It can recognize that it can mesh uh, these two surfaces, the circle and the outer hole, and then sweep them to this far surface. So we'll just click done through here. The next thing to do is to do mesh. And so I can choose my volume that I want meshed. I can generate that mesh. If any volumes had failed to mesh, I could use this dialog here to see failed meshes and then work through possible solutions. I can now validate my mesh, so I can check my mesh quality. And you can see here, it's using by default a quality called shape, which is kind of a meta quality that incorporates the size, distortion, scale Jacobian, and so forth into a heuristic value. So I've got qualities, shape qualities over 0.1 or 0.2 or tend to be pretty good. So this is a pretty good mesh. So go ahead and click done. Now I want to define some boundary conditions. Let's define, maybe what I want is this is a block that's being pressed on the top surface and held on the bottom. So let's define a node set. Node set, we'll give it ID of 1. We'll call this the base surface. And I want to select by surfaces. You'll notice that the power tool has now again brought me over to an entry in the command panel. I'll select that surface for my node set. If I'm applying a pressure, I need an integratable region, so I need a side set. So I'll create a side set. I'll call this pressure surface. And again, using a surface. So I've selected that. Back to the power tool, define blocks, block 1, and we'll call this test coupon. And again, this is going to be a volume. And we want to choose volume 1. Notice that as I've been doing these operations, that my model tree is now populated with those sets. And as you can imagine, when I select the base surface, you can see the nodes that are selected. As I select the pressure surface, you can see the elements or sub-elements that are selected, and then the block, the full elements. Now, the last thing to do, Cubit really does focus on just defining these sets, and then you reference those in your input files in your downstream applications. There's some basic functionality for boundary conditions and materials, but those don't translate necessarily well to a lot of various solvers. So I tend to just stop here with defining my boundary conditions and go to export the mesh. And again, I could export out to the Exodus mesh format, but I could also choose Abacus. So I'll go here and I'll choose I want to export. This is my first mesh. There are some advanced options for most of the exporters that you can choose if you want. If you have some additional information about your geometry. Also, you oftentimes are rewriting a file that already exists. So I oftentimes like to force an overwrite. And there we have it. We have our first mesh that we've created in Coreform Cubit. The one aspect of this that you didn't see was you didn't see the imprint and merge. So I do want to at least show the imprint and merge on this geometry just through the command panel. So I'm going to go ahead and I know that there's a command called delete mesh. I'm going to then use the geometry operation web cut. And I'm going to sweep on this volume. This is again the web cutting approach. The web is this blue entity that is what we call the web, and it's going to cut our green volume. So now I have this additional yellow volume there. And this yellow volume is completely mergeable. I don't actually need to run the imprint operation, but there is a default imprint merge, and I can just select my two volumes to imprint and merge. And there's a little bit of information that now I've got this one surface that's been consolidated. That's what I expected. And I can now, again, through the command panel, I can reassign my mesh scheme and build a contiguous mesh. So that's the next little step that you might find beyond the power tools, is to start using the command panel. The next thing that is also kind of a next step, that's maybe your next 15 minutes, is journaling or scripting. I tend to like to work with my journal file side by side with my Qubit session. I have a separate monitor, a vertical monitor that I'm not showing here, but I tend to put my journal editor on my vertical monitor so that I have a lot of space for my mesh. A useful tool is that we can actually import our history tab that I mentioned, and it pulls in all the commands that I've been running. And if I were to then play this journal file, it would replay all the commands that I had run, including those exports and the remeshing and the web cuts. There's a lot of stuff in here I can obviously clean up, like my undo groups, and maybe I don't, I maybe I know I want to do the web cut so I can edit my journal file. But crucially, another thing is that by clicking this little Python icon, it will convert my journal file from a Qubit command language to a Python script, where the workhorse is this command method in our Qubit module that issues those Qubit commands as a string and runs them. And so now you can do a whole bunch of stuff with F strings, import NumPy, do a lot of computations to then drive the script that you can run either inside of Coreform Cubit or in an external Python environment. So we'll leave a deeper discussion of the journaling and Python scripting to a different webinar. But that's a little hint now to your next 15 minutes of Coreform Cubit. So with that, I'll go ahead and I'll open up to questions.
Thank you so much, Greg. While we're waiting to see if any questions come in, somebody did ask if the recording will be available. Yes, anybody who's registered for this webinar, we will send you the recording by Monday at the latest. We'll wait a minute to see if anybody is typing. In the meantime, thank you very much for joining us. If this prompts you to have more questions about Coreform Cubit, you can reach me anytime at sales@coreform.com. You can also find more detailed webinars for more advanced use cases on our website and in our YouTube channel. And if you have any other questions after this webinar is finished, you can go to our forum, forum.coreform.com. That's a great place to ask technical questions about your use of Qubit. Greg, we do have a question. Have you seen simulation data management tools which enable you to run Qubit on a digital database platform?
Yeah, I'm not aware of tools that do support that. Other than there is an open source project from Sandia called Dakota, which is really more of an optimization platform, but they have some aspects of simulation data management. What I'll say is that the Python interface to Qubit, as well as the way that journaling works and Qubit being able to run from a command line, it's definitely fairly straightforward to add it to a tool like that, if that's of interest to you. But I don't know of any native integrations that exist today other than the Dakota effort, as well as some internal efforts at Sandia.
Thank you. Do you have any recommendations, Greg, for facet-based geometries?
Yeah. So a facet-based geometry is not what's called a BREP. BREPs are kind of the traditional CAD format. Facets are like STL files. Coreform Cubit has some limited functionality for facet-based geometries. Things it can't necessarily do, for instance, are say heal an STL file. So, but it can mesh an STL file, especially like with tetrahedral elements. It effectively kind of uses the underlying facets as a virtual geometry. But my recommended workflow is you heal and prepare your STL file in some other tool, like MeshLab, or typically if you have like a 3D printer, you'll have like from an EOS, you'll have some meshing or some STL healing software there, and then bring it into Coreform Cubit. And then a lot of the same commands you can use on the geometry. But it's definitely not a recommended workflow. If you have a cat, if your choices are a step file or an STL file, definitely work with the step file.
Thank you. How does Cubit fix non-watertight geometries or overlap of objects?
Yeah, that's a great question. Let me maybe just show that here real quick. So let's say I'm just going to build up a geometry real quick. Breed X1, cylinder radius 0.3, height 1. Let's move all to in the Z direction by like 0.9. So maybe what you can see here is I have a slight overlap of my geometry. I say slight, it's actually really big, but just for highlighting the tools. Um, in the command panel, again, this is maybe what you'll kind of hit in like the next 15 minutes. There are some cleanup options that can say find gaps and overlaps, but I can detect these gaps and overlaps here. And again, it says I can remove overlap from say one of the volumes, like the larger volume or the smaller volume, and it's giving me the ID here. So in this case, I know that green is volume 1, yellow is volume 2. So I want to maybe remove the overlap from volume 2 as the command that I'm going to execute. And then that can remove that kind of overlap. Oftentimes these overlaps are very, very small, but they oftentimes do exist. And that's kind of a tool that you can use. And again, it issues some command out here, this remove overlap, that we do, if you really know your command panel tools, I know that I can find that in our Boolean operations as a remove overlap with a few other options. But that's how I kind of would handle that. Sometimes you'll have like a surface that maybe doesn't quite connect. And there are some functionalities for creating, say, new curves. So oftentimes we'll join vertices together to create new curves, and then create a bounding surface, and then I'll do stitching. But that gets pretty deep and involved. Oftentimes what I'll say is, especially as a new, if you're new to analysis, oftentimes I find geometry that has a lot of overlaps or issues with water tightness is I go back to my design engineer, and work with them on the native CAD model to improve, either the setup of that model or export out to a native format rather than step. And I find that typically is a better approach to fixing these issues. But since that's not always possible, we do have some bottom up capabilities for that.
Okay, that's it for questions. Thanks again, everybody, for joining us. You'll see the recording in your inbox soon. And feel free to visit us anytime at our website or on our forum. Thanks again, Greg. Everybody have a great day.